All right, 5.4, last section of chapter 5. We are going to solve systems of equations by elimination. So we have some steps to follow. Some people prefer this method over the other methods we've learned. And it can be very easy. So the way we are going to do this is first, we're kind of just going to subtract one equation entirely from the other one. So the way we're going to do that, the first step is we're going to line up each term and equal sign vertically. So I have two equations here in problem A, so let's do that first step. So I'm going to rewrite both of them. So first I have 2x, oops, let me make that a little bigger. 2x plus 6y equals 6. Now, I want to write the second equation underneath of it, but I need to line up the variables so that way they're vertically just on top of each other. So my second equation here, I'm going to write it just below. So I have negative 4x minus 6y equals negative 6. So I've just rewritten it so that way they're directly on top of each other. I have my x's, my y's, and then the stuff on the right side of the equal sign. Now, step 2 says determine which variable can cancel, and cancels in quotes. What we mean by cancel is terms that will add to 0. Okay, so if you hear the word cancel, a lot of times we're just trying to add things to 0 or multiply things to 1. So it's used loosely, but essentially we're just going to try and eliminate one of the variables, hence the name elimination. So if we notice, if I add 2x and negative 4x, I'll get negative 2x. But if I add positive 6y and negative 6y, those add to 0, and that's giving us what we call that cancel. So those are the variables that will add to 0. So because of that, we're going to go ahead. Step 3, you only do if none of your variables will add to 0. So we can skip that one for this problem. So then we'll go to step 4, where you're going to add the equations vertically. So here's what that looks like. I'm going to draw a line underneath, and we are going to just add these terms. So top to bottom, I have 2x plus negative 4x, or you can think of it as 2x minus 4x, and that will give me negative 2x. Then we said that we had 6y minus 6y, and those add to 0, so I don't need to write anything. You could write plus 0y, but you don't have to. And then this will equal 6 minus 6 is also 0. Now, I do need to write this 0 because I need something on that side of the equation, okay? So this is what we are left with. For the sake of completeness, I will just put in here plus 0y. Okay, so now if I rewrite this whole equation up here, I have negative 2x equals 0. Now to solve, we will divide both sides by negative 2. This looks kind of interesting over here, but 0 divided by any number will equal 0. So my final answer is x equals 0. Okay? So we have solved for this variable. Now, similar to our substitution method, in order to solve for the second variable, we have to put this value for x back into one of these equations and then solve it for y. Okay? So in this case, I don't think there's one equation that's necessarily easier than the other. Maybe this top one, since there's no negative signs to worry about. So let's rewrite this equation with 0 in place of x. Okay, so we're going to put 0 in place of x in this equation. So let's do that over here. So I have 2x plus, oops, I just did not do the step I said I was going to. Instead of 2x, it would be 2 times 0 plus 6y equals 6. 2 times 0 is just 0, so I am left with 6y equals 6, We'll divide by 6 on both sides and get y equals 1. So final answer, we have x equals 0 and y equals 1. Okay, so that's that elimination method. Let's try that with another example here. Okay, so I'm going to go ahead and rewrite these. Actually, I think they're written pretty well. They're already on top of each other. So I'm just going to draw a line underneath. Now, look what happens if we add these together. I have negative 6x and then minus 5x. So if I combine those, that's negative 11x. Here's where we get to eliminate something. We have negative 3y and a positive 3y. So if we combine those together, that will add to 0. So I'm going to just have plus 0y. This will equal negative 6 plus 17. You can use your calculator if you need to, but that should equal 11. All right, simplifying over here, I can get rid of the 0y because that doesn't change our equation. So I just have negative 11x equals 11. I'll divide by negative 11 to solve for x, and I get x equals negative 1. Okay, last step, I need to plug or substitute this value in for x in one of my two equations. I'm going to do the second one. You can do either that you choose. So let's rewrite this over here. I have negative 5 times negative 1, because that was our x value. I'll highlight that yellow. Plus 3y equals 17. All right, now we are simplifying. So negative 5 times negative 1, those will multiply together, and we get positive 5. And then we still have plus 3y, and this equals 17. Now I need to isolate our variable. So to get y by itself, I'll do the opposite operation, subtract 5 on both sides. Then you get 3y equals positive 12. To finish solving for y, divide both sides by that coefficient, which is 3. And you get y equals 4. So x equals negative 1 and y equals 4. All right. Now, I want you to try this one by yourself. It looks a little tricky, but remember, if we just have x by itself, we can think of a certain number being written in front of it, okay? So use the elimination method. Go ahead and try and add these equations together and solve for your x and y variables. Go. All right, so I added the equations together, and I ended up getting 0x minus 8y equals 0. I simplified this down and got y equal to 0. I plugged that into the second equation over here, and then I simplified and got x equals negative 3. All right, let's move on to D. All right. So if I want to add these together, you're going to notice something. So I'm going to write some stuff. I don't want you to write this down yet because I'm going to change it later. So don't write this down. Just watch for now. If I add these equations together, watch what happens. I have 3x minus 6x. So that would get me negative 3x. I have negative y and another negative y. So if I combine those, I get negative 2y or minus 2y. And then this will equal negative 3 plus 15, which would be positive 12. So notice I added these equations together, but I still have two variables. So there's something different we need to do with this pair of equations. So I'm going to go ahead and erase this, and let's talk about this for a minute. So adding the equations didn't quite work. But what if I subtracted the second equation from the first equation? Or in other words, what if I took this entire second equation and I put a minus sign in front of it here? Now, this might look a little weird, but bear with me. So if I think of this as distributing this negative sign into each part of that second equation, all that will do is change the sign of each term. Okay, so let's write this over here. So if I distribute this little negative sign, which remember, we can think of it as a -1. If I distribute that to all three terms, then that would change my equation in this way. I would have positive 6x plus y equals -15. Okay, so do you see I just distributed -1, so this became positive 6x, this became plus y, and this became -15. Now, let's see what happens if I use this equation instead of this one when I'm adding these together. So I'm going to rewrite this equation on top of this one, so that way we can add them. So I have 3x minus y equals -3. So now let's add these together, and I think we'll get something different. So I have 3x plus 6x, that's 9x. Now I have a -y plus y. So a -1y plus 1y, that will add to 0 y's, which is what we wanted. And this will equal -18 if you add those two numbers together. Now I only have one variable. I just have 9x equals -18 because 0y is just 0. So let's divide both sides by our coefficient, and we should get x equal to -2. Now I can take that and plug that back into one of our two equations. I'm going to plug it in, let's see, let's do it with the first equation. So x equals -2, let's plug that in up here. Bring this down. So now I will have 3 times -2 minus y equals -3. 3 times -2 is -6. Let's get the variable by itself, so I will add 6 to both sides. So now we have -y equals 3. It looks like we're done. Our variable's by itself, but I can't have this negative sign in front of my variable for my final answer. So how do we get rid of that? You either multiply or divide both sides of the equation by -1. So I'm just going to divide both sides by -1. And now I have y equals -3. All right. So in this equation, or in this example, we had to multiply one of the two equations by -1, which changed the sign of each term, and that allowed us to add them, and one of the variables combined to 0. Now, I want you to do problem E by yourself. You're going to have to do something similar. I'll give you a hint. Notice we have a plus 6y in both equations. So if you multiply one of these two equations by -1, one of these should turn into a -6y. So go ahead and try this one on your own. Once you think you got it, unpause and see if your work matches up with mine. All right, I got x equals a -6 and y equals a -1. If you got something different, check your work and see if you made a mistake somewhere. We are going to skip examples F and G. You can go back and do those as extra practice after the video. That would be very helpful. But I want to go to example H. Okay, now let's take a look at this. First, notice my two x values, if I add these together, they're not going to add to 0, and same thing with my two y values. But also, if I just change the signs, that's also not going to help me too much. I'm still going to get a number or a coefficient attached to my variables. So for these ones, we have to get a little more creative. In this case, we're going to have to multiply one of the two equations by a number so that we get numbers in front of our variables that will add to 0. So for this problem, I notice that in the first equation, I have negative 10y. The second equation, I have negative 5y. If I multiply 5 by 2, it equals 10. So if I multiply this equation by 2, then I would have the same number in front of my y values. More than that, if I actually multiply it by negative 2, then this will turn into a positive 10. And a negative 10 and a positive 10 combine together to make 0. So I am going to take this whole second equation and we're going to multiply it by 2. This way we'll be able to eliminate our y variable. And I'm actually going to change it. I think I said it earlier. I want to be multiplying this by negative 2. So if we do that, we will distribute our negative 2 to each term in our second equation. Once we do this, negative 2 times negative 5x is 10x. Negative 2 times negative 5y is plus 10y. And anything times 0 equals 0. So I have my new second equation. I'm just going to copy the first equation as it is on top. Now I can add these two equations together and notice my y variables are going to combine to 0. So I have negative 7x plus 10x. That will give me 3x. Negative 10y plus 10y is 0y. And 27 plus 0 is just 27. That does not look like a good 27. We'll just do it like that. Okay, so I can get rid of that 0y, so I just have 3x equals 27. Divide both sides by 3, and our x equals 9. All right, our last step is we need to substitute this 9 into one of these two equations for x and solve it. So I want you to pause and do that really quick, and then unpause and see what you get for y. All right, I got y equals negative 9. If you got something different, check your work. Okay. Now, let's go to letter. These are all letters. Letter I. All right, so again, we can't just add these equations or subtract them as they are. We're going to have to do some multiplication. There's a couple ways we could do this, but the first one I notice is for my x's, I have 8x and 4x. So I know if I multiply 4 times 2, that gets me 8. So if I multiply 4 by negative 2, I would get negative 8. So 8 plus a negative 8 would add to 0. So with that being said, I'm going to multiply this second equation by negative 2. Once I do that, I will get negative 8x plus 4y equals positive 40. So I got that from distributing this negative 2 to each of these three pieces. All right, and then I will copy the top equation on top. So 8x minus 8y equals negative 8. Adding these, I get 0x minus 4y equals 32. If I divide both sides of this equation by negative 4, I get y equals negative 8. Remember that 0x just disappears because it just adds or multiplies to 0. So y equals negative 8. If I take that answer and I substitute it into one of these two equations, I'll just do it with the second one. We then get 4x minus 2 times negative 8 equals negative 20. Whoopsies. Simplifying, I have 4x. Two negatives being multiplied give me a positive, so this is plus 16. I will subtract 16 from both sides to get the variable by itself. So now I have 4x equals negative 36. You can use your calculator when you're doing those bigger numbers. Lastly, divide both sides by 4, and you should get x equals negative 9. All right, if I'm going too fast, don't feel bad if you need to pause the video and just take some time to write stuff down or things like that. It's totally okay. We are going to do one more together, so let's do the very last problem. So this is letter L. Okay, so if I look at my top equation, I notice 5 and 15. I think 5 can go into 15 some number of times. If we do some trial and error, we'll notice 5 times 3 gets us 15. And there's already a negative in front of this x term, but this one's positive. So if I just multiply it by 3, this term will still be negative, and so then I'll have a negative plus a positive, and that will end up getting me 0 if they're the same number. So I'm going to multiply my top equation by 3. So once I do that, I'm just distributing it to each term. We will get negative 15x plus 24y equals negative 18. I had to think about that one for a minute. All right, and then I'll just copy the bottom equation as it is. So I have 15x minus 24y equals 18. So I want to add these. Before I do you notice anything? Anything interesting about these two equations? Well, if I look at my x terms, I have negative 15x and positive 15x. Well, I know those are going to add to 0x. Then I have 24y and negative 24y. Interesting, because that's also going to add to 0y. Equals, if I look at the right side, I have negative 18 and positive 18. Those add to 0. So this actually just simplifies to 0 equals 0. Now, that's a true statement. 0 does in fact equal 0. But I don't have any variables to solve for. So we didn't do anything wrong. What we actually discovered is these equations are essentially the same equation. You just have to do some math or some operations to kind of reveal that. So if you ever eliminate equations and you end up with a true statement, in other words, we have 0 equals 0, that's a true statement, then our answer for this is actually all real numbers. What that means is it actually doesn't matter what numbers I plug in for x and y. This will always be true because our x and y variables just end up eliminating each other. So this is a very unique case where something like that happens. I'm actually going to backtrack. I said that was the last one. We're going to do one more. I want to do example K because we're going to find a very similar outcome as we did with this one. So let's go back and take a look at K really quick. I noticed right away I have just plus y, and I know I could think of there being a 1 here. And in my second equation, I have negative 2y. So if I multiply this equation by 2, I'll get 2y, and then I have negative 2y. Those will add to 0. So I want to multiply this top equation by 2. As I do that, I get negative 16x plus 2y equals negative 8. Then I will copy the bottom equation, so 16x minus 2y equals 10. Okay, now, like the last equation, I have a positive and negative 16x and a positive and negative 2y. So when I add those, I know those will add to 0. So 0x and 0y. So far, this is looking very similar to the last problem. But now let's look at what happens on the other side of the equal sign. Negative 8 plus positive 10. That gets me positive 2. So now, 0x and 0y, those are nothing. So I have 0 on the left side of the equation and 2 on the right side. So this is a false statement. 0 does not equal 2. So this is incorrect. And because we got a false statement and there aren't any variables to solve for, this set of equations, there is no solution. So this means it does not matter what numbers I plug in for x or y, I will always end up with a false equation. These two equations will not simplify in that way. Okay, so no solution if you end up getting a false equation. If you end up getting a true equation with no variables, then your answer is all real numbers. All right, that concludes section 5.4, and that concludes chapter 5.